Thank you for joining us for this tutorial video covering the SoundXR platform. In this video, we'll walk you through how to set up the new immersive processing system, SoundXR Image, on the DME processors. This system is a collaboration between Yamaha, NEXO and Steinberg.
We'll guide you step by step from the basic configuration of the DME series to connecting SoundXR Image controller and finally integrating with Steinberg's Nuendo. SoundXR Image is an immersive audio system developed under the concept of immersive experiences for everyone by Yamaha, NEXO and Steinberg. It enables intuitive, object-based mixing, allowing you to create deeply immersive audio environments. Specifically, it offers precise 3D, spatial, positioning, and immersive reverb effects using advanced 3D reverb processing.
SoundXR Image runs on Yamaha's and NEXO's latest signal processors, the DME series. If you own a DME 7 or other models in the DME series, you can activate SoundXR Image by purchasing and installing an additional license. SoundXR Image operates as an audio component in the DME, enabling object-based mixing.
You can control object position parameters and more using Yamaha's SoundXR Image controller software, Yamaha mixing consoles, or Steinberg's DAW, Nuendo.
To use the SoundXR Image component, you need to activate a license. For example, with a DME 7, activating one license enables a 32 object in and 16 channel out component. With two licenses, you can either use a 64 in, 32 out component or one 32 in, 16 out component. For DME 10, a 32 in, 16 out component is available without any license, but adding two licenses allows a configuration with up to 128 in and 64 out. Before we progress, let's take a look at a typical system connection as shown in the diagram. In general, SoundXR Image requires the use of two separate networks. The first is for audio signal transmission, which uses the Dante protocol with the DME processors. The second is for control signals, used for configuring the DME and sending parameters to and from the SoundXR Image. Now take a look at the rear panel of the DME. You'll see several Ethernet ports, two for Dante, primary and secondary. You'll need to at least connect the primary port here, and one separate port for control. Be sure to connect them correctly. They would normally use two different networks or at least be separated by VLANs. And now let's begin to configure the DME. SoundXR Image is supported on DME firmware version 2.0 or later. To update the firmware, first download the latest version of ProVisionaire design from the website. Connect the PC with ProVisionaire design installed to the same network as the DME control port. Refer to the ProVisionaire design user guide for connection and firmware update instructions. After updating, follow the device license activation guide to activate your license. Activation procedures may vary by region, so please check accordingly. Once activated, confirm the license installation from the DME front panel by selecting Device Information and then License. Now let's configure the DME. Open ProVisionaire design and start in offline mode. On the project sheet, place your DME device. The window that appears has a few sections which I'll explain briefly. Capacity refers to the number of Dante input and output channels the DME can handle. This can be expanded by activating additional licenses on the device. We cover this process in another video. DME supports various sampling frequencies. By default, it's set to 96 kHz. The sample rate you choose should match your other Dante devices within your system. Number of devices refers to how many DME processors you're using in your system. Unit ID. This is how the ProVisionaire software communicates with the DME device. By default, this will be set to 01. If you have more than one DME in your system, then you'll have to manually set the ID numbers on the other units for them to communicate normally within ProVisionaire design. There are separate videos showing how to do this if you're unsure. Once you've added your DME device, double-click to open the configuration screen. From the left Components tab, drag and drop the SoundXR image component. In the pop-up window, select the system scale you'll be using, so the number of inputs and outputs. The component ID will be displayed, and you'll need this later when linking with SoundXR image controller and Nuendo. If you plan to use multiple SoundXR image components on a single DME, each component will have a unique component ID. This ID is essential for correctly linking each component to its corresponding controller or DAW. For this example, let's choose a 64 in and 32 out system, and its component ID is 40,000. Once the component is placed, you'll see many arrows representing input and output signal ports. These arrows are unlabeled by default, but you can add labels by clicking a port and selecting Label from the Properties window. You can also click the three dots button to open the Label Settings window. Click Set Default Name to apply default labels. Take a look at the component. Audio flows from left to right, and the component functions like a matrix mixer. On the left, you input object-based audio signals. On the right, you get the rendered output from the SoundXR image. SP01 and onwards are speaker outputs. Sub SP01 and onward are sub-renderer outputs. Aux outputs are assignable within SoundXR image and useful for LFE routing. The reference port outputs oscillator signals from SoundXR image, which can be used for transfer function measurements during speaker tuning. Next, let's set up the inputs and outputs for the component. From the Input folder, drag and drop Dante in, and then drag and drop Dante out. In a simple system, you can connect Dante in directly to the SoundXR image component, and then to Dante out. Of course, you can insert other components like fader or EQ in between. Just keep in mind that the DSP has a finite processing capacity. If too many components are added, the system may fail to compile, so remember to check the system capacity quickly by clicking the Compile button near the top of the window. Once the configuration is complete, synchronize with the DME. Open the synchronization window from the Online button and select To Device. If ProVisionaire Design and DME are on the same network, the DME will appear automatically. Select it and click Online to sync. DME setup is now complete. After completing the DME configuration, let's proceed to setting up the audio connections. As mentioned earlier, we'll use Dante for the audio routing, and the setup will be done through Audinate's Dante controller. First, let's set up the inputs. Here we'll assign Dante Virtual Sound Card, DVS, as the audio interface for Nuendo, and route the audio to the DME. Though for a live immersive event, we will be patching from a mixing console to the DME. Launch DVS. Set the appropriate number of channels and select the correct network interface, and then start it. Open Dante Controller, and while referring to the channel numbers of the DME's Dante in components you just configured, connect DVS to the DME. Next, for the outputs, connect the DME to your amplifiers, Dante output interface, or loudspeaker processor. In this video, we'll connect it to NEXO's NX Amp Mark II power controller. The SoundXR image component on the DME is controlled using the SoundXR image controller. You can download it from Yamaha's website for Mac OS or Windows. connect to the same control network as ProVisionaire Design and the DME, and then launch the application. Actually, ProVisionaire Design can be closed now. SoundXR Image Controller works independently, so after your hardware is set up, there's no need to keep multiple applications open. When you open the SoundXR Image Controller, the Welcome window appears. Select New here. Next, choose the configuration for SoundXR Image Component. Since we set up a 64 object system on the DME, select 64 object. Once the main screen appears, open the system window to configure the connection with the DME. From the left Setting tab, you can configure the DME connection. First, select the network interface of the PC connected to the DME. If connected properly, the DME will automatically appear in the Select Device window. Then connect the component. The displayed number is the component ID shown in ProVisionaire Design. After setting it up, choose the sync direction and click the Online button. The connection with the DME is now complete. Any parameter changes in the app will be reflected in the DME in real time. Now we can begin the SoundXR Image system design with the speaker position coordinates. Click the Speakers tab to open the Speaker Settings screen. Since SoundXR Image performs object-based rendering based on speaker coordinates, this is a crucial parameter. Unhide the speakers you'll use, press the On button, and enter the coordinates in meters. X is width, Y is depth, and Z is height. After entering the coordinates, click the Check button to confirm the speaker positions. You can also import speaker position coordinates, saving a great amount of time once they've been exported from the NEXO speaker simulator. Click the Import Export button below, then select Import to load a .mys file and apply the speaker information. To verify speaker connections, use the oscillator. Click the oscillator button to open the settings. Use the play button at the bottom right to toggle the oscillator on or off. Press the OSC button for each speaker to play the oscillator signal. Be careful with the volume. Also, if the OBA mute on the left is enabled, no sound will be output. Make sure to check the main fader position as well. In addition to gain, you can also configure EQ and delay for each speaker. Oscillator signals are also output from the reference port of the SoundXR Image component, which can be used for speaker tuning. Next, let's configure speaker zones. Open the Zone tab to access the Zone Settings window. Speaker zones allow you to select which speakers will render object audio. For example, you might want the performer's voice rendered only from front-of-house speakers, while sound effects come from ceiling speakers. Zones can be assigned per object, and up to 32 zones can be configured simultaneously. By default, all objects are assigned to Zone 01, but since no speakers are assigned to Zone 01, no sound will be output. To configure the zone, click the gear icon for Zone 01. Here you can select the speakers to assign to Zone 01. This enables audio rendering from the selected speakers. The coordinates below configure the rendering area conversion feature, which maps logical coordinates received from DAWs like Nuendo or mixing consoles like Rivage PM series, relating them to actual speaker coordinates. The edges of the logical area are automatically mapped to the orange highlighted physical area. You can freely shape the area using 16 vertices. Don't forget to set the center position and the high, mid, low height levels. This feature is only relevant when using logical coordinates. It doesn't apply when controlling objects directly in the SoundXR Image Controller, or when receiving physical positions in Cartesian coordinates from an external device such as a tracking system. That completes the SoundXR Image system setup. Your object audio should now be playing. In case you've not seen it yet, Don't miss our other video about getting started with SoundXR Image Controller for object-based mixing. Alternatively, refer to the SoundXR Image Controller user guide available on the website.
Finally, let's look at integration with Steinberg's DAW Nuendo. One of the key advantages of integrating SoundXR Image with Nuendo is that you can handle both audio and position information simultaneously. This makes working with pre-recorded content much more efficient, as you don't need to program object positions separately. SoundXR Image is supported by Nuendo version 11 onwards. Using the built-in VST multi-panner, you can work with object audio. Bear in mind that Nuendo needs to send two types of signal to the DME, audio and control. Make sure both are properly connected. We already looked at Dante Virtual Sound Card for audio. For control signals, configure the PC's network port to connect to the same network as the DME and SoundXR Image Controller. Let's open Nuendo and create a blank project. As with any project, configure the audio system in Studio Settings. Here, we're using Dante Virtual Sound Card. Now, create an output bus for using VST multi-panner. Open Studio, Audio Connections, and click Output to view the current output bus settings. For simplicity, delete the current settings. Then, create a bus that supports height panning, such as 7.1.4 channels. Do not assign any audio device to this bus. Next, configure the rendering settings. Open Studio, External OSC Renderer Setup. Set your DME as the External OSC Renderer. OSC data transmission must be active. IP address must be the IP address of the DME control port. The port number is 50528. The OSC header is YOSC rec set proc component 40,000 OBA object logical position. Here, 40,000 is the component ID shown in ProVisionaire design. It can vary depending on the design, so confirm the correct one. Then, configure device port mapping, which links audio output ports to object numbers. Click Map All to assign them sequentially. Now, add as many audio tracks as you need. When adding tracks, select the multi-channel bus you configured earlier as the audio output. Next, go to Project ADM Authoring. Select OSC External as the format. For simplicity, check Auto Connect Object Buses. Select the audio tracks you want to convert to objects and then choose Create Objects from Selected Tracks from the Functions menu. This automatically converts the tracks into objects and creates output buses for object audio. The object ID here corresponds to the object number in SoundXR Image. Now, let's use the VST multi-panner to control SoundXR Image objects. Open the Mix console and double-click the multi-panner above the fader to open its window. Moving the panner updates the object position in SoundXR Image. You can also write and read object movements using Nuendo's automation features. By integrating with Nuendo in this way, the workflow for object-based audio mixing is simplified, saving time and increasing creativity. Object positions and movements can be programmed in Nuendo even when disconnected from the SoundXR Image system.
As you can see, SoundXR Image offers such a wide range of features without becoming overly complex. Don't miss the other videos in this series about SoundXR to learn more about system design, software configuration and hardware control. Dive in, get immersed and enjoy object-based mixing.